Question 15 is an algebraic fraction question, and we're going to have to write it as a single fraction in its simplest form. Now we've got 2x over x minus 1, take away 7x minus 3 over x squared minus 1. And if you were to just pretend that this was fractions with numbers, and it was, say, 1 over 4, take away 3 over 5, for example, straight away I'd hope that the one thing you would do is aim to get the denominators the same, and that's exactly the same with algebra. Now this is going to be quite a long and complex method. However, please, please, please do not skip this question and think that you cannot do it, because at the end I will show you the bare minimum that you need to do if ever you see a question that looks like this. Alright, so write this as a single fraction in its simplest form. First thing I need to do is get the denominators to be the same and do any cross multiplication that I need to do. Now, I know from my trained eye, and there's no reason you can't recognise this either, I know that what we've got here is x squared minus 1. And I know that that is something called the difference of squares. It's a rule that you will learn, the difference of squares. And that's when you have a square number, in this case x squared, take away, for the difference, take away, another square number, in this case 1, because 1 times 1 is 1. And whenever you have a square number take away a square number, you can always put that into double brackets, where the first term is the root of your first term and the second is the root of your second. So in this case it's going to be x and x. Now because there's a negative product of 1 there, one of my brackets is positive, one of them is negative, and then here goes whatever my root of the square number involved is. In this case the root of 1 is 1. So I need to make my denominators both look like that. Now for the bottom, for the second fraction, that's fine because I know that it factorises into that. But for the first, I've got x minus 1. I need it to be x plus 1, x minus 1. So what I need to do here is multiply this fraction by x plus 1. So what I'm going to end up with, if I write it out here bigger, I'm going to have x plus 1, x minus 1. Because I've multiplied this side by x plus 1, I have to do the same to the top. So the 2x was already there. I'm multiplying it now by x plus 1. So that's my first fraction dealt with. My second fraction is going to have the same denominator, x plus 1, x minus 1. And because I haven't had to change this denominator, I do not change the top. I keep it as 7x minus 3. However, because there's a negative in between these brackets, between the two fractions, I'm going to bracket off that numerator. You'll see why later down. Okay, so I've done that quite successfully. Now I've got both denominators the same. I can write it as one fraction out of the same denominator, because whenever you have two denominators and you're adding or taking away, the denominator is the same. So in my case, my denominator is going to be x plus 1, x minus 1. Now, my numerators, my top numbers, I'm going to multiply out. So in this case, I'm going to do 2x times by x, which is 2x squared. I'm going to do 2x times by positive 1, which is positive 2x. And over here, whilst I don't have any brackets to expand out, I need to consider what this negative means. Now, it's tempting to just put negative 7x minus 3, because that's what it looks like. However, you've got to keep in mind that this minus affects the whole of this bracket. So what you end up having to do is switching that from a positive 7x to a negative 7x. And that's going to end up needing to switch as well, because a negative and a negative is a positive. So what I end up with here is minus 7x plus 3. And that's quite a confusing thing there because people never understand the fact that the signs change. So keep that in mind. Now I can collect and simplify. I can put my x's with no powers together. There's nothing I can do with that. That stays on its own as 2x squared. Positive 2x, take away 7x is negative 5x. And then I've got my plus 3 on the end that can't go with anything else. And that's all over my x plus 1, my x minus 1. Now I'm nearly done with this question. That's the hardest part in my opinion. I just need to now be able to cancel it down to its simplest form. In order to do that, I need to factorise this numerator. Now it's in 3 parts and it's got a square on it, it's a quadratic. So I'm going to put that into double brackets. Now this takes a bit of practicing. I'm not going to explain it here. You can get the video up or you can ask a teacher. But because I've got 2x squared at the start, I know that one of my first terms of the brackets is going to be 2x and the other one's going to be x. Now I can see that my quadratic expression ends in a positive 3. That means the product is positive, so both of my signs either have to be positive or they both have to be negative. But either way, they multiply together to get 3. So that only leaves me with the number options of 1 and 3. So I know those numbers are going to be going into my brackets. I have to decide which goes where. Now, whatever number goes in this bracket, when you expand them out, it's going to be multiplied by that 2 first. So whatever's here is going to get doubled. So you need to consider that when you're trying to work out what they subtract to. Now the fact that the signs are the same because that's a positive is great. But are they positive? Are they negative? Look to the middle one for that. Look to the sum. Because that's a negative, I know that both my signs need to be negative. Now it's just a matter of deciding where the 3 goes and where the 1 goes. Because one of them is going to get multiplied by the 2. Now I know I need to get to 5. If that was 3, it would be multiplied by 2 and it would give me 6. So I'd end up with negative 6, take another 1, is going to give me negative 7. That's not what I want. So I know that I need to put the 1 there because that'll get doubled to negative 2x. And I'll put the 3 there because that'll be negative 3x. And negative 3x take negative 2x is going to leave me with the negative 5x I wanted. So I factorised the top successfully. That goes over my denominator that I factorised earlier, and straight away I can see that they're going to cancel down. And that's going to leave me with 2x minus 3 over x plus 1. And that's that question solved. As for where the marks are awarded for this question, you get 1 mark straight away up here for identifying the difference of the squares and for factorising that out. So there's your first mark for work-ins. Your second mark is a method mark and it comes from down here. And that's for making the denominators the same. Your third mark is here, and that's for correctly expanding your brackets and having the numerator. And the final mark is an A1 mark for having the answer correct, cancelling out your expressions. And as promised, I said never skip this question because there's always something you can do to pick up a mark. So if you see this in an exam and you're starting to panic because it's the end of a paper, don't worry. Just look at the fractions, rewrite them out. In this case, 2x over x minus 1 minus 7x minus 3 over x squared minus 1. And always think, if I want the denominators, if I want the denominators to be the same, I need to multiply them together. So in this case, I'm going to make my denominators into x minus 1. Let me get a darker pen. I'm going to make my denominators into x minus 1, x squared minus 1, because that's the two denominators times together. Then I'm going to take the bottom of this one and multiply it up there. So I had 2x there originally. I'm now taking the x squared minus 1 up, and I take away this, which I take up. So I had 7x minus 3 up there. I need to times that by the x minus 1 from the bottom of the other fraction. If you can, then just expand this bracket out. X times x squared is x cubed. X times negative 1 is negative 1x. Negative 1 times x squared is negative x squared. Negative 1 times negative 1 is positive 1. So just to reiterate, so it's absolutely clear, you get a mark for doing this here. Okay? So if you can't do anything else, multiply the two bottom numbers together. Question 16 is a circle theorem question. A, B and C are points on the circumference of the circle. The circumference is the outside of the circle. There's points A, B and C. The centre is O. TA and geometry, capital letters are the corners, so TA is this line here, TA, and TB are tangents to the circle. CA equals CB, so those two lines are also equal, and angle ATB, so that's that angle there, is 2x. Now this question wants you to prove that the angle ACB equals 90 minus x degrees. Now, the fact that it's asking you to prove something means that they've already given you the answer. They want you to show workings out to get there. First thing I'm going to do is mark on the angle that I actually want to find, and it's angle ACB. ACB. So that's the angle that I need to prove is equal to 90 minus x. Now, whenever you get a circle theorem question, if it has tangents on it, then I want you to think of the rule where a tangent, which is a line that just touches the edge of the circle, where the tangent meets a radius, and that's that, or where it meets the diameter, but in our case we're interested in a radius. Tangent meets radius is 90 degrees. Radius, tangent, 90 degrees. So by drawing those two lines in, I've made myself a four-sided shape. I've made myself a quadrilateral. And I know that a four-sided shape has 360 degrees inside it. So I know that angle is 90, and I know that angle is 90, and I know that angle is 2x. Now, you may wonder why I'm finding these angles when the angle I really want is all the way out here. However, finding those angles allow me to find this angle, the angle at the centre. Now, before I go on to find this angle, I'm going to state what I've done so far, because in this question you get marks for saying why you've done what you've done, or how you knew that angle was what it was. So in this case, I'm going to say that angle, and I'm going to do this one first, so it's TAO, so angle TAO equals 90 degrees, and that is because a radius meets a tangent at 90 degrees. And this is also the case for TBO. So TBO also equals 90 degrees. Now I know that that's 90 and that's 90, and I know that's 2x. I can start to look for angle AOB. So AOB equals the 360 degrees, that is the four-sided shape, take away the 90 degrees and the other 90 degrees and the 2x, and that leaves me with 360 take away 90 is 270, take away another 90 is 180, minus the 2x. So now I've got an expression there for this angle here. Now the reason I wanted that angle is because of the second rule, and the second rule states that the angle at the circumference is half the angle at the centre. So this is the angle at the centre, this angle is exactly half of that. So if I know that the angle at the centre is 180 minus 2x, then I know angle ACB is going to be equal to half of 180 minus 2x. Half of 180 is 90, half of minus 2x is minus x. So what you'll see then is angle ACB is equal to 90 minus x, and what did our question want? ACB is equal to 90 minus x. So I know when I leave that exam room that those 5 marks are in the bag. Now this is what the marks are allocated for. You get 1 mark for showing that you can find the 90-degree angle. You get the second mark for stating that that's a reason. You get the third mark for taking them away from 360 degrees. You get the fourth mark for something that I haven't actually put in. So I would have lost this mark in an exam. I'm only just realising I haven't given a reason for this answer. So I need my reason, and that is the fact that the angle at the circumference is half the angle at the centre. So angle at circumference is half of the angle at the centre. So that's actually my fourth mark, and then my final mark is there. So the 5 marks: method mark 1, method mark 2, method mark 3, method mark 4, answer mark 5. There are alternative ways to answer this question, so see a teacher if you think yours is correct.